Mary McCarthy here with episode 2 of the Small Language Show, the new show by Arcee.ai. You can learn all about us over on our website. We build, train, work with, deploy small language models, as you can guess from the title of the show, joined by my co-host, Mark McQuade. I'm in Los Angeles. He is in Miami. Welcome, Mark. Hope you're doing well. And I know you're going to dive in and introduce us to the guests and the topic of today's show.
Yeah, absolutely. Hey, everyone. Good to be on again for show 2. But we'll let Kamran and Hunter here with AWS introduce themselves, and we can dive into the topic at hand. You want to go first, Kamran?
Yeah, my name's Kamran Khan. Very happy to be here. I lead our business development go-to-market teams as part of our Inferentia and Trainium products here at Amazon. So.
Absolutely, yeah. And I'm Hunter Carlisle. I'm a senior architect on Kamran's team here at AWS. I work with customers to, kind of take their language model and vision model workloads and kind of bring them to the real world on our purpose-built accelerators, Trainium and Inferentia. So very excited to be here and chat with you, Mark and Mary. And yeah.
Perfect. Let's dive in then, I guess. Let's see. Get a little bit more detailed in the nitty-gritty on exactly what, Trainium and Inferentia are. Obviously, those are two different things, right? Talk about explain, what one does over the other, and some of the benefits associated with why someone would use Trainium and Inferentia today.
Yeah, absolutely. So a little history, right? So Amazon and our team specifically, so we're a team in Amazon called Annapurna Labs, and we're a hardware team in a software company, which is usually kind of a little strange. But what we're focused on is building various types of accelerators used in different spaces. So our team has kind of built Nitro, and Graviton is one of the other products coming out of our team. And so recently, over the last few years, we've been investing in AI and machine learning accelerators. So the first one we developed was Inferentia. This was released in 2019. It was really good at solving inference acceleration, delivering 2x higher throughput than other instances on AWS at the time with GPUs, and was able to do it by saving customers 70%. And those were really good for the types of models of that day, right? So even 5 years ago, this is the world moves so quickly, but even at that time in 2019, it was like CNNs and maybe some really small BERTs, right? So transformers were just coming on the scene. BERTs were becoming super popular. BERTs were still small, 100 million parameters. Maybe a big one was 500 million parameters. And Inferentia 1 was great. But now fast forward to today, models are getting bigger. Even small models are getting bigger, right? We're talking billions of parameters. So I think, Mark, what do you consider small, right? Like 3 billion or maybe a billion parameters, right, these days? And now they're growing very large, right? 70 billion, 100 billion, multi-100 billion. And so the successors to Inferentia, we have Trainium and Inferentia 2. So Trainium is a training-focused accelerator platform, kind of looking at the way we've architected our silicon to the server, to how we're deploying it in the rack, and then the software that we're deploying it with to expose it to customers. And when you're thinking about it, like Inferentia and Trainium at the accelerator level, the ML chip level, they're the same. And we actually use the same ML chip in both accelerators. What we change is the configuration, right? So Trainium instances have more total accelerators, more ML chips per box, right? And they have higher bandwidth connectivity between nodes for distributed training for extremely large models, things like that. So in a big nutshell, that's kind of the accelerators we have. And the difference between Inferentia and Trainium really just kind of spelling out as their namesake suggest, right? Like where are the focuses of these systems, right? But really similar architecture there.
As a marketing person, I have to say I love those names because it's rare that you get names that are catchy, concise, and that actually describe the products, that it's not some
No,
random.
it works, right? Because it's like, hey, what do you need for inference acceleration? Inferentia, done.
Yeah.
The challenge, it's like a double-edged sword though, because customers are like, well, I can't run training on Inferentia, or I can't run inference on Trainium because that's a training platform. It's but I think all of those lines as the new Gen AI boom we're in, all these lines are getting kind of blurred anyway, right? So it kind of makes it's a double-edged sword. It's nice though.
Interesting. Yeah. So Mark, Arcee's team has been collaborating closely with AWS using Trainium and I believe Inferentia, or you just Trainium. You're going to tell us that. How's that collaboration been going?
Yeah, it's been going great. I mean, Kamran and team have been fantastic to work with, working through some of the early, engineering challenges that we've had. But I mean, at the same time, when working away from GPUs, it can be quite a lift. It hasn't been, massive lift in that sense, right? As it can be, right? I've worked on alternate platforms before, and it can be a big lift. But yeah, I mean, we've seen great results. We have a blog that we'll be releasing very soon, which will detail some of the specific things around, the training and inference around Trainium and Inferentia, as opposed to using GPUs, which will really get into the detail of that. But all in all, it's been fantastic. I think one thing that I'll say, this team, the Kamran's team, extremely talented team that are doing huge things, and I really hope that we can keep building it up, right? I mean, because GPUs today, they're expensive. There's a shortage at times. There's a lot. Kind of monopolizing that market is good for really no one, right? So opening it up for more chips to be able to train large language models is only beneficial to everybody, the entire community. So I'm excited.
Absolutely. Next time we have them on, we're going to have to ask them to bring the fun thing about hardware is like showing stuff. So I don't know if you have anything sitting there, but next time.
I have the tips, but they're at my desk and I'm sitting in this room. I forgot. But next time for sure.
Absolutely. Yeah.
Well, I guess I could jump into questions. And I mean, speaking to a little bit, building on what I had said there was, this has been done before, right? I mean, people have tried to build, GPU alternatives. Maybe not as successful, right? I mean, NVIDIA is bigger than ever. So I guess how are you going to win? How are you going to win in this market? How are you going to succeed? And by win, I don't mean like beat all these other players. I just mean, how are you going to be successful in this market? With all the competition and with someone clearly leading the race.
Yeah. Actually, Hunter, why don't you kind of take this one? And
yeah, absolutely. That's a great question. I think if you look at both Trainium and Inferentia, one of the things that I think Kamran mentioned is, both of these devices have been purpose-built for machine learning from the ground up, right? And in particular, with these specific deep learning workloads in mind. If you go back, before 2012, which is when folks first started using GPUs for deep learning workloads, the people were using CPUs, and there was a lot of potential where people knew we could push to bigger models, beyond 1 million parameters and such. But it wasn't until someone decided to try using one of these graphics cards for training these large models that we really saw this acceleration into bigger and bigger models, and we saw a lot of advances in the language and the computer vision space. But at its heart, a GPU was designed for different types of workloads. They weren't necessarily designed for machine learning from the ground up, and that's one of the things that we really, when we were looking at customers and their workloads and their training needs, we made a lot of intentional design choices within our architecture specifically for these types of models, these language models and these vision models. So there's nothing unnecessary or unneeded for the task at hand of either training or inference. And I think that's a huge differentiator. And you can see that with things like, the energy efficiency, Trainium compared to kind of comparable accelerated, instances that are not Trainium, you see about 25% more energy efficiency, right? Because there's just less power consumption for kind of the same level of performance. And, we've really designed everything at the hardware level, from the ground up for these workloads. We've also extended that into our software development kit. So the Neuron SDK, which is our interface to actually work with these chips, we've designed it such that you can work with a variety of frameworks. Your existing, PyTorch or TensorFlow code should be able to port over relatively smoothly. We want to support, the latest and greatest distributed training techniques and libraries. So we have support for things like the Megatron distributed training framework, as well as our own Neuron distributed training framework. So, we really want to meet folks where they're at as well. So everything is intentionally structured around the needs and the requirements of our customers. AWS just in general, one of the great things about AWS is we learn from what our customers are doing, and we see what works and what doesn't work across many, many different customers. And we can bring that to bear very, very quickly and really bring new features relatively quickly to our devices there. I don't know, Cameron, if you have anything to add to that point.
No, I think that's a kind of tells the story. I think one of the other things that we're working on is because it's a difficult space, right? Like Mark, you were mentioning, right? Like NVIDIA is not dominant in this space without good reason. They've invested for decades on building their ecosystem and partnerships with some of the strongest, ML frameworks, libraries, and innovating at that level at a constant pace for a very long time, right? So I think one of the other things that we're trying to do as well is partner with leading, emerging, interesting new techniques and developers as well. Like, and I consider Arcee as part of that, right? Kind of not just following the pack, right? It's like, okay, well, if ever, like if Meta created just Llama 2 and it's wildly successful, it's very useful, it has a lot of benefits. Just following in their footsteps, that's fine. But I think that's where it kind of makes it interesting for us as well, is like what Arcee is looking into and how to make services and tools that are more than just repackaging open source, but actually providing value to customers, right? Making it easier, cheaper, faster, and ultimately more useful for their end customers as well. So I think that's one of the things that we're working on very closely is partnering and supporting kind of the leading voices in this space. And then, success test here is basically offering customers choice, right? It's not necessarily, hey, we're going to become the next NVIDIA, or that's, I don't think, in our thought process right now, but we want to give customers choice. I think customers deserve choice as well, flexibility, and we want to democratize these compute units, right? Because it's becoming kind of who has the deepest pockets. Well, if you have the deepest pockets, then you're going to be successful in this in generative AI, and if you don't, then hey, too bad. No matter how good your idea is, and so we want to make everyone's ideas equally accessible, and and drive that forward in the market.
Yeah, that's great. I mean, because you hit it, right? It's as a startup, we're a startup, right? As a startup, compute is a scarce resource and it's an expensive resource. So having the ability to access compute, from the likes of companies like Arcee, as opposed to, massive organizations, is very beneficial, obviously, as we try to scale, right? Or else, it stops us from scaling, and then, it stops any startup from getting up there. So there's this domino effect of the whole thing. So,
what's funny is, someone, sorry, a little bit of a tangent, right? But I saw this post from Mark Zuckerberg on Facebook, and he was, I forget what he was talking about, but he was referencing Gen AI, and he was like kind of talking to, I forget who he's referring to, but he was basically saying that he's like, you guys can't, our model, Llama 3 is one of the best models. It's going to be better. You guys won't be able to do this because I bought all the GPUs. He's just kind of putting it out there, right? Just like you're saying, he has deep pockets. He can buy all the GPUs. He's going to make it harder for everyone else to get GPUs. And that's part of their strategy, right? The bigger you are, you're going to hold back. So we want it to be equal merits out there. So
agreed. I think that's something again, a little bit off topic, but I think that's something that really impresses me about Mistral, to be honest, right? I mean, they're building, Mistral is by far the best 7 billion parameter model of the day right now, right? And Mistral does not, I mean, they have deep pockets, they got some big funding rounds, don't get me wrong, but they don't have the pockets of Meta, right? They don't have the pockets of Google, right? They don't have those kind of resources and money, but their model is by far superior to the other models that have been released by those companies that I mentioned. So I always have a large amount of respect for Mistral for doing that. So that's great.
Yeah,
I mean,
a little plug on the Mistral side, right? So we just announced a partnership with Mistral just this morning as well.
Nice.
So you're going to see better collaboration between our two teams, Mistral models coming on Trainium Inferentia, so that Arcee customers can take more advantage of this as well. So we're pretty excited about that too.
Yeah, love that. That's great to hear. I guess I'll kind of ask one question to put you both on the spot, in the sense of, what do you think about, you could say one thing that, Trainium, let's stick with Trainium for now. What is the one thing that Trainium is great at compared to alternatives? Like, is it, and maybe it's, 7 billion parameter model, something like, what is it that is great at compared to the alternatives?
Throw it to Hunter.
Yeah. So throughout my career, I've done led a lot of data science teams, in the pre-LLM era, as well as done a lot of large scale kind of distributed training. And one thing that I really appreciate about Trainium, is it scales up fairly nicely. So when you're looking at the larger models and also the smaller models, you might want to train them very quickly, or in the case of like a Mixtral, which is a mixture of experts model using many an ensemble of smaller models, you're going to need a larger kind of cluster or compute resources. And Trainium, it scales up very, very nicely relative to some of the work that I've done on similar training jobs on GPUs. It's not too different from training kind of single node to go up to multi-node. It's not a huge heavy lift, and the tooling is getting a lot better as time goes on to make it even easier. Ultimately, I'd love to see a day where it's nearly the exact same experience training on single node versus multi-node, and we're not quite there yet for Trainium or for kind of other accelerators. But I think Trainium, it's been a really, really nice experience kind of working on these workloads in recent months. Kamran, I don't know if you have thoughts on your end.
I did want to say, I think, Mark, you mentioned a little bit earlier, is like, there are a lot of accelerators coming out for Gen AI, right? We're not the only ones out here. We've been here since 2019. So we have a little bit of, I would say, like a mild head start here compared to some of the ones that we see coming now. I think Microsoft also announced some accelerators last year. And what I think is one of the key differentiators is hardware. To a certain degree, you could solve that problem, right? Like, people know what these you could break down Llama or Mistral into its opcodes, and you can customize silicon to make it very efficient. And what happens is generality becomes the hard part, right? Software becomes the hard part. And so that's where I think a lot of our focus has been, more than our hardware, is building up good software, good integration points, and wide partnerships with leading ML frameworks, right? And we have a long way to go. We have a very long way to go. But just that's where I see a differentiator as well, is the focus that we're placing on software and integration with open source, rather than focusing on proprietary and closed ecosystems, right? Like, I think that's a North Star for us right now, is that we know if we are the only fish in a small pond where we're the big dog and there's only, to access everything will have to come through us, it's just not going to be scalable. It's not going to be successful, right? So we want to make it as scalable and flexible as possible. And that means engaging in the open source community as efficiently as possible. And, this is a path we're going to be on for a while. Not to say we've accomplished our goals, but this is kind of like a guiding principle for us.
Yeah, that's great.
I was
Sorry,
just
go
going to
on.
say, I think some of the work that we're doing with like the Hugging Face team, around the Optimum Neuron library is indicative of some of that, where, Optimum Neuron is, the goal is to take, maybe existing Hugging Face transformers code that you might be using, and, with as few as like 2 lines of change of code, port that over and run that same script or that same workload on Neuron, on Trainium or Inferentia. And, I think, meeting customers where we're at, embracing the community, working to add more framework support is something that's going to continue to be important, especially, I think we're at an interesting point, where the past couple of years, folks have been pushing the limits at how big you can make models. But I think with things like, the mixture of experts and what you guys are focusing on, the namesake of the show, smaller language models, I think we're going to see many more opportunities to kind of, have new state-of-the-art architectures that, maybe are using a smaller number of parameters in the 1 billion to 3 billion range, or, new novel architectures beyond transformers, beyond diffusion, which are kind of dominant right now. I think it'll be interesting to see how that evolves. And we're really partnering with research communities and the open source community to drive some of that and make sure that there's good support on our platform for those things.
Yeah, I like that. It's great to hear those kind of things. And I mean, I guess lead me into my next question, which, I mean, we kind of touched upon it, right? So you mentioned Mistral, right? You just announced the partnership with Mistral. Actually, I'll ask a quick question first, because I'm actually a little confused. So this will be great for me to hear. Like, is Trainium and Inferentia power Bedrock?
Yeah, so that's a great question. Yes, I think in the Bedrock utilizes many different accelerator platforms from AWS, right? I will say. So they use our standard GPU platforms like P4 and P5, and now they're adding more models running natively on Trainium. So Trainium is heavily utilized. It's just kind of as part of the accelerator pool. Bedrock is scaling so quickly as they have to take as much compute needs as possible. I think what you'll see is more and more models deploying first on Trainium, even being served in Bedrock. So yeah, Bedrock uses everything.
Yeah, I think what's nice about Bedrock is, as a user, it kind of abstracts that away from you, right? You're just focused on the API interface with the model, and the Bedrock service kind of behind the scenes, it will handle finding the right compute resource. And, as Kamran mentioned, some of those compute resources that are used for these models are Trainium and Inferentia as well.
Nice. And yeah, I mean, tell me about some other customer success stories. Like, who else is using, Trainium and Inferentia today? I guess it'd be good to hear of some companies that probably have some well names. That'd be probably good to hear the community hear some of those names. Yeah.
We already talked about Mistral kind of making their announcement today that they're going to be partnering with us, and we're super excited about that. We also did this partnership with Anthropic last year as well, to bring their Claude models out onto Trainium and Inferentia. So that's going to be actually happening very soon now as well. And so we're going to be a leading partner for them, kind of moving forward on kind of the foundational model providers. I think we are still very much in our early days right now of customer success, but what we've seen right now is guys like Deutsche Telekom, which kind of shared about their story at reInvent last year, where they're able to kind of reduce their costs and reduce the latency of their assistant models that serve their customer service agents by 25% by moving them over to Inferentia 2. And similarly, like Leonardo was one of the customers running stable diffusion models, and they saw an 80% reduction in cost by moving over to Inferentia over traditional GPU instances. So we have more of these success stories on our site, but I think the best days are ahead of us. I think still, right? I think what we're doing with the Arcee team is going to be very exciting, right? But we also starting to see more customers train models on Trainium and post them back to Hugging Face as well, right? To share them more with the world. So we have a collection of those now, so you can look for models trained on Trainium on Hugging Face, and you'll see a whole bunch of these models popping up. or you can visit the Optimum Neuron section of the documentation where you can get references to that as well. Kind of see other customers, what they're doing.
Yeah, and I mean, I'll end by saying we're hoping, to put Trainium and Inferentia in the hands of many other customers too, through what we do in our product, right? As we're implementing Trainium and Inferentia under the hood of our product, we're now taking that into enterprises, everywhere. So hoping to spread out that across to many other customers.
Yeah. Fantastic partnership collaboration happening. Thank you both, Kamran and Hunter, for joining. I'll put both of your LinkedIns in the comments so that people know where to find you. Anywhere else besides obviously the AWS blogs and LinkedIn, Twitter, anything like that we should give a shout out to for people who want to follow your work?
Yeah, I will say the AWS Neuron documentation is probably the best place if anyone wants to learn more and get started. We have a lot of really, really good examples, kind of hello world level examples that are very small, simple models, things like BERT, like Cameron mentioned, all the way up to large scale distributed llama models as well. Lots of great documentation and good explanations of some of the underlying theory. And if you want to see more about our specific architecture that is underlying the hardware, you can actually see those details on our documentation as well.
Awesome. So, I'll throw that in the comments then after the show. AWS Neuron. Perfect. Yeah. And anything from you, Kamran?
No, I think that was great.
Just keep an eye out for the upcoming blog, which is co-authored by, I believe, Arcee and AWS.
Yes.
So awesome. So we'll say goodbye to you guys. We'll have you on again soon. And thanks so much for joining.
Absolutely. Thanks for having us.
Thanks, Mark. Thanks, Mary. Have a great one.
All right, we're going to drop these guys and we are going to move into segment 2 of the show, which is on model merging, what we started with last week. Let's bring in Charles, who is our resident expert. He is an Arcee senior research engineer and the founder of MergeKit. Hey, Charles, how are you?
Hey, I'm great. How are you?
Good, good, good. So last week, as we all know, we had a lot of questions about model merging, which is why I thought it'd be good to make this. This might be a segment every show. We'll see. I don't see questions coming in today, but I thought it'd be a good chance to chat for you and Mark to chat about some of the work I know you were doing over the past week or two on MergeKit and model merging.
Yeah, I don't know, Charles. Maybe you want to just call out the new model stock method you added quickly over the weekend. That's a pretty cool method. There's been some interest.
For sure, yeah. So a very cool paper came out of Naver AI Labs recently called Model Stock. I read that. I just immediately had to add it in because it's such a cool analysis of some of the geometrical properties of fine-tuned of the same model. So that's available in MergeKit now, and people have been seeing some great results with it. It's a great merge method. I know you've played with it some, Mark. Do you have any?
Yeah. I boosted a model that I had, one of our continual pre-trained models that we have on patents. I boosted up the performance, over to the best performing model I had is a merge model using Slope with another. It's a Llama 2 base, so I used another Llama 2 base model. Orca 2 actually was the other one, and I increased the performance from the base checkpoint, the base continual pre-train checkpoint, about 6% or so. Using that new method, I got it up to about 9%. So increase across the OpenLM average eval. So it's been great, good for me. Good. It's a good, easy to use. No, you don't have to actually do it and you can tweak any parameters. So it's actually a great little method that based on that paper. So
one thing that's great and kind of surprising about that method is if you read the paper, they did all this careful analysis, and the method it's designed to work basically where you've run the same fine-tuned job, same data, same model, same hyperparameters, but with different random initializations, like a couple times. That's what they based their analysis off of. But of course, I put this in MergeKit, and everybody's just using it with whatever random models they feel like. And despite not being what the algorithm was designed for, it still works really, really well. So it surprisingly, well, I don't know about surprisingly, but very robust and effective merge method.
Yeah, and I will actually drop the paper in the chat. And let me bring it up. Awesome. And I will drop it in. Yes. I mean, it's probably good also, Charles, maybe chat a little bit about some of the things you're working on. I mean, you don't have to give away any secrets, right? We like to do big announcements and big drops when we do stuff, but kind of just maybe touch upon briefly some of the things you're working on and we're working on as a team would be great.
Sure, yeah. So I'm always reading all the new papers out and seeing what people in academia are coming up with in terms of new merge methods and doing that. So that's a constant thread of work. I'm also with the team working a lot on trying to get merging of different models trained from different foundation models working. So if you have, for example, a model that was trained off of Llama 2 and a model that was trained off of DeepSeek Coder, so a different foundation model. Traditional merge techniques, well, the ones that are available today don't work for that use case. So they're depending on linear mode connectivity between. Well, so that property doesn't hold between these different foundation models. So a lot of what my research effort is going to right now is working with the team at Arcee to try to enable that kind of merge. And
that's going to be very, very big. I think that's something that everyone is waiting to see. What will happen around those types of merges, and we're confident that that's something we're going to be able to do, which is exciting for everybody. And we're going to put it in MergeKit. It'll be open source. Everyone can play with it. So yeah.
MergeKit, which hit, we haven't posted about this yet because there's kind of too much happening to keep up with the posts, but you hit 3,000 stars over the weekend, I believe. So awesome to see. I have a question about how you work. To what degree does what you see happening on the GitHub repo sort of inspire you, either just because it's awesome that so many people are using MergeKit, or make you think about the further threads of your own work?
Right. Well, I'm definitely very heavily informed by posting an issue on MergeKit on GitHub is a great way to steer the direction that I work. I read all of those and I see the problems that people are having and the things that they want to do that aren't possible yet. And that factors very heavily into my decision making in terms of what to prioritize next. And
awesome.
Most of the work that I'm doing is just right there up on the GitHub. You can actually follow along with a lot of what I'm doing, just based on some of the branches floating around.
And Mark, I know you do a lot of merging. What are you like? Are you driven by? Because when I see your Slack messages, and I'm kind of like, Mark seems to be having a lot of fun with it, but I assume it's more than fun that's motivating your own research.
Yeah, I mean, obviously it is fun, but no, I mean, there's a massive, in my opinion, there's a massive amount of business value to be unlocked through model merging that is probably not well known presently, right? If people think that merging is fun, it's cool, and you can merge a couple models and maybe try to game the OpenLM leaderboard on Hugging Face and have a great model up there, which can, right? Don't get me wrong, like it's something you can do and it's something cool and fun, but there's actual business value to model merging and what we're doing and how we're building it out. And a piece of that is not model merging by itself, but actually pairing model merging with continual pre-training, right? So I see a lot of times, there's a lot of things that said online about merging's great, but why not just fine tune, or fine tune versus merging? I actually don't look at it as fine tuning plus merging. We don't, as a company, right? We look at it as pairing fine tuning with merging to really unlock the massive opportunity of model merging. I mean, I think it's revolutionary model merging. I think it's the next massive wave of transfer learning. So we're absolutely having fun with merging and doing a lot of fun things, but trying to build towards unlocking some great business value, which we've done so far, and we will continue to do so.
And on that note, a question for both of you, Charles, in your role as the more research development side, and then Mark, you still, I'm sure, to a certain degree, are taking calls with prospects and all that. To what degree is awareness of model merging growing?
You want to go first, Charles?
Sure. So I've been sort of watching interest in model merging explode over the last 6 months. It's gone from being at least in terms of the large language model space, a very obscure thing that a few people, were playing with online, to a thing that suddenly it's now more surprising when someone hasn't heard of model merging than when someone has, which is a pretty big change from where things started.
Yeah, that's a big flip. Yeah, interesting.
Yeah, it's definitely taking off. It's if you're a dev or an engineer in the NLP LLM space, model merging is probably you probably know what it is at this point, right? I think that's something. Even the business world's catching on now, though, a little bit, right? I mean, we still have to educate somewhat because it's so novel and it's so transformative, but it's absolutely catching on in the business world. People are and that stems from MergeKit and its impact on the community, right? As it spreads out in the open source community, and then into the devs from within the open source community, those tailwinds bring the back into the enterprise and the organizations through the developers and engineers that now work for those organizations. So it's absolutely kind of spreading, kind of like a wildfire, really.
Awesome. We actually had, since our last show, you guys published an academic paper. Do you want to, either one of you, give sort of the summary on that? I know it's old hat for you, but for viewers who might not have seen it.
Yeah, I'll let you go. So I'll put the link here. Actually, that's actually good. Our last show was the day before we dropped the paper. So yeah, I'll drop that in too.
So much happening. Yeah.
That was multiple days ago. Why are we still talking about it? Yeah. So I mean, we published that paper on Archive recently, just talking about MergeKit, the library, and how it's structured, what it's for, and it's also a sort of an overview of some of the research that's been done in the space of model merging, particularly as it pertains to language models. But we tried to cover as much of the field as we could. So it's both sort of a systems paper detailing what we've built here with MergeKit, and also an overview of what techniques people have come up with in this space. Do you have anything to add on the paper, Mark?
No, I mean, it's just a good, there was so much behind, MergeKit itself as a repository. It had a lot of, obviously, traction and a lot of community, it was community driven, essentially, right? It's open source, but there wasn't a lot published on the academic, kind of ideology behind it, right? So, putting that out into the wild was great for us to do. And also, I mean, it allows more people to understand kind of the depths of MergeKit and what it does now and what it will grow to do, which is always beneficial, right? I mean, a repo is great, but it kind of doesn't provide that depth of detail on exactly what's happening with under the hood of the code and all that. So I think it's huge. It's great, and we'll keep putting out more papers, right? Papers, because we're doing a lot of great things that are so novel that we want the community to be fully aware of what we're doing and what we're trying to accomplish in the space. And so you'll see a lot more from us coming up in the.
Yeah, you guys are busy. I've never worked this closely with the research team, and it's exciting to see everything happening. A lot to keep up with. Give the mention too of the white paper. That was a case study on, obviously some overlap with the academic paper, but more focused on continual pre-training and model merging together, right?
Yeah. The white paper was definitely focused on, what I touched upon a few minutes ago, is that, we see a lot of the true power in pairing model merging with continual pre-training, right? The ability to have this pre-trained or fine-tuned domain-specific model that is now, fully aware of your private and proprietary data that you've trained, and then adding in, the merging capability to fuse it with another model, right? We see that as the absolute massive true power, superpower, really. And, that's where you really unlock the true business value instead of the kind of just playing around, right? So that's what that white paper is focused on. It's focused on showing, what we're doing in the space from continual pre-training and then pairing it with model merging and evaling it, right, to show true proof on the benefits of what happens to a model after you do combine these things.
Awesome. Yeah, amazing stuff. People can find all that on, obviously, our LinkedIn, our Twitter, our blog. If not, come to the show and we're going to give you every couple of weeks a recap of all the exciting stuff. Any final thoughts of the week on model merging, Charles?
I mean, I think it's great. Not really a thought. Yeah,
Keep merging, as Maxine said last week.
Mm-hmm.
Maxine Levon. And
one thing that I would like to one thing that I would really like to encourage is for people to play with the parameters more. So there are some example configs in the MergeKit repo, which are a good place to get started for merging. But I see a lot of people thinking that that's all you can do. You have to use these sets of numbers, and there's not much room for experimentation there. That's the opposite of the truth. So getting the hyperparameters for merging right is, frankly, it's still more of an art than a science. But there's a lot of room to for any given use case to get something really spectacular for what you want. If you just spend some time experimenting with these different parameters.
So hashtag keep merging, hashtag keep experimenting. Love it. Okay. What about you, Mark? Final words?
No, I like what Charles said there. I think it's start, and I'm the same. It's like, I have to play with hyperparameters more as well when it comes to merging, right? It's kind of you trying to experiment and then iterate and experiment, but it's kind of like in the pre-training world, right? Experiment more with the hyperparameters that you're using in your train run as you would as you're training a model. It's the same thing in merging, right? So, and I think one thing that is great to kind of focus on too, which is what we do really, is focus on an end goal, right? Like what are you merging for, right? I mean, if you're merging just to gain, some competitive advantage on an eval, that's great. But if you have an actual business use case, merging will help, right? So just think about that and then work backwards from your end goal, right? So because we're trying to bring merging more to the forefront of kind of, I don't know what to say, but like instead of just merging for fun or excitement, like merging can have true value and true impact, and that's what we want to show, right? We want everyone to see that too. So I encourage people to do that too, like think backwards from an actual real life use case you may have and merge from there.
Awesome. Yeah, I love that ending with really practical, concrete advice. On merging, I'm going to end with a spoiler that I don't know if I'm allowed to say, so I'll keep it hypothetical. There may be a MergeKit hackathon coming up soon, potentially sponsored by Arcee. So we will keep everyone in the loop on that. Keep your eyes peeled on all of our socials, and we may be announcing that soon. So awesome. Yeah, thank you, Charles, for joining. Thanks, Mark, for co-hosting. And just to wrap up for the entire show, also keep an eye out for the blog co-authored with AWS about Trainium. That'll be on your screens coming up very soon as well. So lots happening. We will see everybody in 2 weeks, where we have special guest Maya Akeem, I believe, who does a lot of playing around with model merging and is going to talk about her experience with that. So see everybody in 2 weeks, and thanks so much for being here. Take care. Bye-bye.
Thanks for having me.